Psychokinesis or telekinesis is a claimed psychic ability allowing a person to influence a physical system without physical interaction. I'll present this very interesting paper on robotic telekinesis. If you're interested in this, go ahead and scan the QR codes there to access its online resources overall. My task right now is to showcase what this work is all about and why we should care about teleoperated robot arms in a cost-effective, unobtrusive way. A couple key things about the authors. All of them have a technical, very rich research background in robotics or computer science, and they all work and study or are associated with Carnegie Mellon University in Pennsylvania. The TLDR on this paper is it's all about achieving natural, unobtrusive human control for a robot hand and arm. The goal overall is to have a remote teleoperation system that's very cheap, smooth, and it's any kind of probe or marker or glove free. Designed to work with a single RGB camera and achieve full imitation in real time. There is a serious problem here to tackle. It's an under-constraint problem, which is that, well, no two hands are really the same, and it's also difficult to derive smooth motion from just 2D. How they trained their neural network, which is what they use to get a bunch of systems together to get smooth motion, is that they used online videos with hands. They used data sets that have hand-eye coordination essentially to train gesture recognition. In their result, they essentially came up with a hand-to-robot hand with smooth, responsive, safe, and intuitive control demo, which they then used to evaluate how well it performs using untrained personnel who were using the robot in various examples. So here's what's going on. It's a system that has an X-arm robot arm and a 16th degree of freedom Allegro robot hand, and it also has the laptop RGB camera. The camera captures an image stream of a person, the operator on the left, whilst they attempt to communicate with the arm on the other side of the room. Each captured image at 30 Hz is retargeted into a pair of robot commands, one for the Allegro hand and one for the X-arm, which place the robot hand and arm in poses that match the hand-arm pose of the operator. This capture retarget command loop allows the operator to guide the robot remotely and complete tasks, and at the same time the operator can see the robot arm mimic their operation in real time. On the far right there's an example of the X-arm and its Allegro hand and effector. They are being operated to hold a baseball, and this is already a very complex grasping task. A quick mention for Frank Mocap and OpenPose. They're both pose extractions libraries. Frank Mocap uses 3D motion capture and from video or image, and then estimates poses, whereas OpenPose is all about getting to a real-time multi-person system to detect human body, hand, facial, feet, and such things. You can also see that there's actually two distinct branches of processing going on here, one for the hand and one for the arm. They used 3 datasets to train their neural networks. The Freihand dataset from Freiburg was used as ground truth, whereas the YouTube-derived videos come from the 100 Days of Hands dataset. Epic Kitchens was used because it has a very low noise hand-eye coordination perspective data set for hand poses. Here's the overall control pipeline. From the visual teleoperation pipeline, poses are first received, then inverse kinematics computed, and then to achieve some smooth movement, these kinematics must also be filtered and resampled. And we can see that the hand is also getting resampled. A final safety clip is performed before joint angles are sent to the motor controller. Their hand retargeting network also has an input-output structure, and the goal of this function is that it takes in the hand pose and figures out how the human hand would semantically align with the Allegro hand. They use the multi-layer perceptron, or MLP, to solve this problem. In short, it computed joint angles that might result in collision, and these were the resulting stage discouraged with the use of weights. That way it was less likely that the robot hand would collide with itself in operation. Operators completed tasks with this kind of setup. So they had to do tasks like pick up a dice toy, or pick up scissors, or open a drawer. And then compared to a baseline, in which case they used the DexPilot system, which is a much more complexly set up multi-depth camera post-tracker system baseline. So their telekinesis system in the resulting phase outperformed DexPilot baseline in 7 out of 10 tasks, remember, with a single camera. This performance was actually equal or similar in the 3 tasks where it didn't outperform it, so it came up to par. The key takeaway from the comparison with the baseline is that, well, this new solution had much better results with exceptionally simple setup. It was fast and smooth and intuitive. It still struggled at the more complex stacking tasks. There wasn't any kind of force feedback involved, and robot hand-eye coordination was quite a bit more essential. They were dealing with an under-constraint problem, but the system still performed at a reliable 30 frames per second, even though despite the heavy computations involved. It was relatively super simple and struggle-free as a teleoperation solution, and many operators actively emphasized that this was very much the case. It was very easy to use it. It was built using readily available datasets derived from body hand videos on YouTube.